Hey Lexi,
What?
do you have all your derivatives memorized?
Yeah.
You
forgot the negative. First, we're going to go over the power rule. So if you have a function that is like this is a situation where we have to use the power rule, and it would be like this. Which might look kind of confusing, so I'm going to show you an example and it'll all make sense. So you can have this function. You're going to follow that formula. So you're going to multiply the exponent by the coefficient. Now you're going to differentiate term by term, so this is like separate from that. And then with the 10, you can think of it, there's x to the 0, and then the 0, if you bring that down, it would be like 0 times 10. So no matter what's after that, that's just going to cancel and be 0. So you simplify all this out, you're going to have 10x to the 4th plus 9x to the 1/2. And that is derivative. So now we're going to talk about the chain rule, which you use when you have a composition of functions.
But what is a composition of functions? A composition of functions is when you have a function inside of a function.
Alright. When you're taking the derivative of that, it's going to look like this. And we're going to do an example. So when you come across a function like this, it's helpful to differentiate between the inside of the function and the outside of the function. So you make a little chart, the inner function and the outer function. You can see the inside function is x squared minus 5. In the outside function, you're just going to focus on the x raised to the third, and you're not really going to pay attention to that because you focus on that over here. So first, you want to take the derivative of that. So that's going to be, use the power rule, so you're left with 2x. And you multiply that by the derivative of just that, which would be multiplied by 3. And you leave that squared, which you just use the power rule outside of the parentheses. You can simplify this. You're left with 6x times x squared minus 5 squared.
Sometimes we say that chain rule is the derivative of the inside times the derivative of the outside. And remember, when in doubt, derive it out.
So now we're going to do the product rule, guys. So that's when you have
the derivative of f of x times g of x.
that derivative equals
F prime of x g of x plus f of x g prime of x.
so you're taking the derivative of the f of x times the g of x, and then you're adding the f of x times the derivative of g of x. So let's do a problem. Okay, so in this problem, we're going to differentiate the equation 2x plus 1 times 3 of x. Okay? In most problems, you can actually distribute like this one, but in other problems, you can't, so we're just going to show you a simplified version of the product rule. So, in this equation, this portion is going to be f of x. Just say that's f of x. So the 2x plus 1 will be, and then the 3x will be g of x. So you have to take the derivative of f of x first. So the derivative is just 2. And then you have to multiply it by the g of x, because that's part of the equation. So 3x. And then you add f of x, and multiply by the derivative of g of x, which is just 3. So that's going to be h prime of x equals that. And then from there, you can also simplify. So you have
6x plus 6x plus 3. And from there you have
12x plus 3 equals h prime of x. So now, guys, we're going to use something called the quotient rule. Yay! So, for this formula, it's going to be... So that means you have pretty much a function over another function. Equals...
f prime of x, which is that, the derivative of just the top, times g of x, which is just the normal bottom, minus the function of x, and then the g prime of x, and then all of it's going to be over g squared. So g squared put it in, yeah.
Alright, so now we're going to do a problem using the quotient rule. So for the problem of the quotient rule, we're going to do the equation h of x equals 2x plus 1 over 3x. So we're going to start out by naming our variable. So up here, this is going to be f of x. And on the denominator, that's going to be g of x. So using the formula, you're going to take the derivative of the numerator and times it by the denominator. So you have 2, which is the derivative of the numerator, then multiply it by just the denominator, so it's going to be 2 times 3x. Then you do the minus of the opposite, so you're going to do the normal numerator times the derivative of the denominator. So you're going to do 2x plus 1 times 3. And now, you have to square the bottom. Always remember to square the denominator. So it's going to be 3x squared. That's h prime of x equals that. So now, from here, we can simplify out the equation.
So you have h prime of x equals 6x minus 6x plus 3. Minus 3. Minus 3. Distribute the negative. Minus 3. Distribute the negative. Yeah. All over 9x squared.
And from there, you cancel more stuff out. So h prime of x equals negative 3 over 9x squared, which then again simplifies even further to h prime of x equals negative 1 over 3x squared.
Beautiful.
Hey Lexi,
What?
do you have all your derivatives memorized?
Yeah.
What's the derivative of sine?
Cosine. Did you study for your physics test?
I did. Do you know the derivative of sine?
Oh, yeah, of course you do. It's 1 over radical 1 minus x squared. You've come so far.
Lexi, what's the derivative of cosine? Negative sine. What's the derivative of e to the x?
E to the x.
What's the derivative of log base a of x?
1 over x natural log of a.
Lexi, what's the derivative of natural log of x?
What's a linkage institution?
A linkage institution.
What's the
is something-
derivative of a to the x?
A to the x natural log of a.
Megan, what do you want to
What you
be?
gonna do when
What
you
do I
come
wanna be?
for you bad
What do you wanna
boy,
be?
bad boy.
When I want to be a star.